Good afternoon, sir. This group 12 trying to present their project, and the project in hand right now is lossless image compression using MATLAB. Lossless image compression using MATLAB. I will start by introducing myself and my group members. I'm Koshile Ashekoluwa, and beside me here is Ogumero Progress.
Ogundiran Adebolajo Martin.
The name is Momodu Victor Olaika Desmond Olatomowa.
Now we've introduced ourselves, sir. Now, in front of the screen, what you can see, the page you can see on the screen is basically the code and some explanation about the code written. And on the left hand side of the screen is the report I sent to you before the order to actually make a video of what we actually did. The report just virtually explained the explains what lossless image entails. Our aim of this project is just basically reducing the size of the image and retaining the quality of the image. So sometimes some image can be so large and it's annoying, but we believe many people believe that the quality of the image depends on the size of the image. Well, that's true at some point, but with some MATLAB codes and some tweakings in the code, we can actually reduce the quality of the image and we can reduce the quality of the image and say reduce we can sorry sir we can retain the quality of the image and reduce the size, thereby reducing the size. So our aim is reducing the size and reducing the size and retaining the quality. Now in this page here on my left hand side, I wrote that the primary purpose of this project is to compress the size of the image and still retain the quality using MATLAB for the project. Basically, the technique of this project is to compress the capture image to reduce its size while maintaining its quality. What we all use there, the formula used there or the method used there is just basically the discrete cosine transformation algorithm. It's going to be explained in the code later on, and I've given you the formula, sir, and whatever we are to use. Now back on the code now. On the code, I can see the first line of the code describe a function, vagout. Vagout just simply means the output, the function of the output. That's basically what it means, the function of the output. Then it is assigned to the input. Definitely what I want to get out is the output, and input is what I want to get in. So vagging is a function to collect the input. Then the size of the image, I said the size, sorry sir. The file of the image is saved as image compression 1. Now, since we are dealing with images, there is a need of a graphics user interface here now to display the graphics user interface. We only need to display it once. So that's why the code on line 21 write it as GUI singleton equal to 1. Now on the second line, it describes the structure of the interface. The structure of the interface, like the state of the structure of the interface. That's why it was just simply described as GUI state. It's just normal English. I just simply described it and I assigned the structure to that variable GUI underscore state. Now we have the GUI name, GUI singleton, GUI opening function, the output function, the layout, and the callback. Now a conditional statement was given in. The condition states that if the input, if you input a value and if you input a number of value and the function of the input is a character, execute this this function, not this function, execute this rule stated on line 29, which state that GUI state the GUI callback, that is the callback of the GUI, is equal to strato function virgin 1 whatever. So the strato function does simply create an anonymous function handle. It creates an anonymous function handle of the input. It's as simple as that. So it ends that condition. Then a new condition is checked in again, and which is about the output. The output, then the line also is executed as explained, and that condition ends there. That's just basically about the GUI interface. What we just wanted to pop, because after this presentation I'm going to try and run the code, and you will see, it will be stated clearly how the thing is. It will pop out. So it will just to get I'll give it some commands. Okay, select image. I'll push a button to select image. It will pop out what image. It will take me to the directory, whatever. So that particular, the back end of whatever I'm just saying right now, is now what I want to explain in this line of code. Now this basic line, written as function image compression till axis off to the function of the variable, to the function of the output of the variable down here, is updating. I'm just updating the GUI structures, that GUI that I created. I'm just obfuscating. I'm giving it some commands. I'm giving it some statement. Do this, do that. Don't do this, don't do that. Then if I should go down this line here, when I push a button, it brings out some, I'll like there'll be a push button that will take me to the directory of to the file directory where of the stored file, MATLAB file, where of the stored to the image, to the stored directory of the image stored in that same file, MATLAB directory. So the name of the images, the name of the file is basically images. So whatever image that it can contain, whether it's a BMP image, I gave it we gave it opportunity to accommodate many types of images as much as possible: BMP, JPN, PNG and TIFF. Then the second line is stating select an image file. That is, on the left hand side of the GUI, you will just see a particular, it's just stated there clearly that select an image file. When you click on it, it will take you to the file, to the directory of the file. Oh yeah, please select the images in this file. Then the information about the file is just talking about the directory of the file name. Then the size of the file being the file info dot byte, that is taking it to the lowest possible size as bytes. Then the size is given as size divided by 1024. This now is not talking about the compression of the image. IM show, now we now move to IM show. IM show goes to the file and select, read or select the image. It reads or selects the image. It displays the image in the directory. Now a condition is now assigned again, that if the file name is a character, print error. Like, sorry sir, I'm conversant with MATLAB, even say my Python a bit, that's why I said print. If that condition is a character, since we are dealing with an image, it's definitely an image that I want it to pop out. But if it's a character instead, it will print out error. Then it will give you an instruction that print image file. That's what this line is talking about. Else if it does that, now this is now where the recoding comes in. If it does that, it will now read the file name. Example, like this comment is just talking about whether the file name is saved as chicken dot. I do you agree with me? Chicken dot and jpeg and whatever there. Now that's the file name, it reads it. Then now we now want to check what is the meaning of I, what is the meaning of I. When I started the explanation, I was talking about discrete cosine transformation algorithm. Now if you check line 70 of this code, that's just basically the formula for the cosine transformation algorithm. Now this one, the first line, I is equal to I1, showing that it selects the first row, first all the rows and all the columns of the first three tree or span. Yeah. Then it's now shown that it is double twice. Like it is double twice precision. Then the team DM just simply means that we are just making an 8 by 8 square matrix, 1 to 8 there. Then the cosine transformation, the formula really needed to transform the image or compress the image, is now written there. Then to check, to reduce, like to retain that quality is there, although it will not be perfect, quality will be lost at some point, but it's still presentable and well presentable, not perfect but well presentable. Then if we go to line 3, line 2, the same thing, just the difference in this line 2 is just that it picks the second line, the second column with the second rows, the 3 trays there. Then the third one, it does the same using the third row and third column. So now I am right, then I'm done with the explanation of that. So it's now to now write, the that I am right is I'm just writing the output, compressing the compressed image, the output of the image, just bring it out for me. Like I'm just writing the image to graphic files, and and that will be all, sir. And that ends the code, and I will now run the code to check, to show you exactly what I mean. Select an image. What happened? Oh, I cannot record it here. It cannot be recorded, sir.